Welcome to Maths with Bob. This is the 3-minute series on growth and decay, and we're looking at problem number three about a town of population which we don't know, unknown, P0 or initial population, is increasing by 40% in 8 years, and we need to find the rate of increase of the population after 20 years. Okay, so this is obviously assuming exponential growth. So let's actually go and have a look at how we do this. The first thing is, you can see here we find k as before. We have to find, obviously we assume that the initial population is P0, some population. After 8 years it increased by 40%, and you can see here it's 1.4 lots of the population, the initial population P0 after 8 years. Okay, a 40% increase you can see here, and we substitute it into this particular formula as before. Okay, let's have a quick look. There's another video on this similar sort of problem, but it was slightly different, and you can see that the wording of these problems are quite important. But we obviously divide by P0, take the logs, solve for k, and we get the k as before, ln 1.8 or ln 1.4 over 8, I should say. Okay, so this is our growth constant. Okay, so now what do we do with our growth constant? Well, the first thing to realize is that we are after a rate of increase of the population after 20 years. So we're after a rate. So we're after actually the dp dt. Okay, so obviously dp dt, you might remember these, they're exponential. So obviously the k is the derivative of here. So this is again a function of differentiating with respect to time. So the k will come down the front. Okay, you may need to revise differentiating exponentials, but the derivative of e to the fx is obviously f dash x, e to the fx. Okay, so we can see here that this is the derivative k p0 e to the kt. Okay, now a couple of things here. One of them is that we actually don't know what p0 is, but we do know that what k is. Okay, so we know. Let's go back here. What do we know? We don't know this. We know k. We don't know p0. We do know k and t. Okay, so we substitute all this in, and we're using the k, ln 1.4 over 8, as I was saying. And we just plug all this in, and we need to obviously put in t as 20 years. Let's try and get the rate here. So the rate turns out to be, you can see here, 0.0973 7539 ... I just left that P0 times P0. Okay, this is times P0 on the end here. So the population is increasing. You can see here nearly 10% after 20 years. Okay, so if you have a quick look, what do we conclude from this? Well, if you like, let's have a quick look. What do we conclude? Well, the rate dp dt is actually about 0.0975. We can see as a percentage it's roughly about 9.75% of the original population. Okay, well, thank you for watching, and bye for now.